Hi students, welcome to our YouTube channel again. So one of our subscriber requested to upload the solution of 2020 exams like AQA. So today we are going to discuss GCSE Chemistry like the higher paper 1, and that was 14 May 2020. Okay, so now we are going to solve question number 1. Okay, so the question is, this question is about the structure and bonding. Which two substances have intermolecular forces between particles? And we have diamonds, magnesium, polythene, sodium chloride, and water. As you know that, like the diamond is actually that formed by intramolecular attraction, because intramolecular mean that is present within one molecule. Alright, intramolecular mean that force that is present in which like within the one molecule, while intermolecular force that is present intermean like international, like intercontinental. So it means that is in between the molecules may be more than one molecule. So it means you have to say that that is present within two or more than two molecules. Alright, so here we can see that the diamond, magnesium and sodium chloride, these all are the intramolecular forces that contain intramolecular forces, while the polythene and water that will contain like intermolecular forces, because as the word indicate, poly mean that many thin molecule join with each other to form a long structure, while as you know that in water molecules, so there are a lot of water molecules that will be joined up through hydrogen bonding, so that make a long structure. So that hydrogen bonding is also the type of intermolecular force. Okay, now the next question. 1.2. Here I shows the structure of three compounds. You can see carbon dioxide, magnesium oxide and silicon dioxide. So now here compare the structure and bonding of three compounds like carbon dioxide, magnesium oxide and silicon dioxide. So first of all, as we know that, okay, so here the carbon dioxide and silicon dioxide that are made up of atoms. So you can say the first one, that is carbon dioxide and silicon dioxide are made up of atoms. Alright, so that is our first. While as you know that the magnesium oxide MgO that is made up of ion, or you can say that is made up of that containing ion, or that is made up of ions. So I am going to write like in a shortcut way to save the time. Okay, the next one, silicon dioxide. If we see that the silicon dioxide and magnesium oxide have chain structures, so it means you can say that here silicon dioxide and magnesium oxide has chain structure. Okay, while the third case, as you know that the carbon dioxide and silicon dioxide containing are made up of covalent bond or having covalent bond, while magnesium oxide having like the ionic bond. So you can write here carbon dioxide and silicon dioxide contain covalent bond, while because that question is 6 marks, so you have to write like as possible as you can find there like the information from the structure and the bonding of three compounds. Okay, so you have to write at least three differences or three comparison. Sorry, not three, here it would be 6. Okay, now here the magnesium oxide that having or that contain ionic bond. Okay, while here as I already told you that silicon dioxide and magnesium oxide that having a joint structure, while here you can add one more thing, that the carbon dioxide have small molecule or small structure. Okay, now the next one from here you can see that like the magnesium oxide is formed by the transfer of electron from the magnesium and like you can say exception of the electron or accept of the electron by the oxygen atom, while in silicon dioxide and carbon dioxide there will be mutual sharing of electron take place. Alright, so now here you can write one more, that bonds in silicon dioxides are single bond. You can see here all are single bond, whereas one silicon, can you see here like the white ball, that is bonded with four different like four black balls, so it means that that is bonded with four oxygen. So you can write here the bond in silicon dioxide are single bond, whereas each silicon forms four bond with each oxygen. Okay, while each oxygen will form the two bonds. And in case of carbon dioxide, you can see that the carbon is present at the center while the two oxygens are bonded with carbon. So both oxygens are bonded with carbon via double bond. So you can also write here the silicon dioxide is single bond, while the carbon dioxide, in the carbon dioxide the bonds are double bond. Okay, now the next one. Okay, question number 2. This question is about the metal and the reactivity series. So here you have to identify the properties of most transition element. So as you know that they are soft metal, they form colorless compound, they form ions with different charge. Yeah, because here in case of, let's suppose we are going to take iron. So as we know that the iron exists in like normally to oxidation state, like that contain the different charges like Fe plus 2 and Fe plus 3, because that will form the compound like FeO and here Fe2O3. So it means that they form ions with different charges. Alright, while as you know that the iron and all the transition elements like mostly they have high melting point. So that is the second statement. Okay, now question number next, that is a student added copper metal to colorless silver nitrate solution. So here is the single replacement reaction occur between copper, here is copper and silver nitrate AgNO3. So as you know that like here is the single replacement of like the reaction is single replacement. Here is the copper will replace the silver and it will form copper nitrate, and silver here. Okay. Now, pale gray crystals forming and solution turning blue. Explain how these observations show that the silver is less reactive than copper. So here, because they form here, you can write like first identification, first observation, pale gray crystal forming. So as the pale, like here, the pale gray crystal forming, that is due to silver. Okay, so you can write here the first one, that is the pale gray crystal forming due to silver, while the solution turning blue due to copper nitrate. Okay, and why? Because here why is less reactive than copper? Because copper displays silver in this reaction. Okay, next question. Here is a student in the is given three metals X, Y, and Z to identify. The metals are magnesium, iron, and copper. Plan an investigation to identify the three metals by comparing their reaction with dilute hydrochloric acid. So normally, if we see in the reactivity table, so we can understand and we can assume that the magnesium, in case of magnesium, iron, and copper, so magnesium is more reactive, then iron, then copper. Okay, so that is the reactivity series. Now here, plan an investigation to identify three metals by comparing their reaction with hydrochloric acid. So as we know that whenever the metal react with the acid, it will form like normally the salt and hydrogen gas that will eliminate from here, or that will produce. So in this case, first of all, we are going to like measure, and we are going to treat each metal with hydrochloric acid. So if we react the magnesium react with HCl, so that will produce here faster bubbles, bubbles of like hydrogen gas. All right, now the next one, if we see that for the magnesium and iron, let's suppose we are going to compare magnesium and iron. So we will see that in iron, when it react with hydrochloric acid, it will produce slower bubbles as compared to magnesium. Alright. Now the third case, when we react like the copper react with HCl, it will form like here is like no reaction take place. No reaction. Okay, because copper lies below the hydrogen. So it means that there will be no reaction take place and no bubble formation take place. Okay, so that is our first comparison, that is our first identification through the elimination or through the production of the hydrogen gas. So we can assume that, or we can easily like you can say identify that the magnesium will be most reactive as compared to iron, and while the least reactive, that will be copper. So that is over the first one. While in second case, you can also write by the temperature, like measuring the temperature change, and also you can compare their solution forming, like the color of the solution, because you have to remember that the magnesium magnesium form colorless solution, while iron form colored solution. While the copper will like there will be no reaction, so it means there will be no solution formation take place. Okay, and also you can like measuring the temperature change, and then you can easily identify it, like the which one is more reactive and which one is less reactive. Okay, now here that is very easiest question, like regarding the isotopes, and you have to find the percentage, like you have to find the relative atomic mass. So as you know that for the relative atomic mass, here will be like the mass number is 203 and the percentage is 30. So we have to multiply through 203 times 30 by its isotopic abundance plus the second isotope mass number, that is 205, multiplier times by 70 divided by the total percentage, that is 100. So you have to divide by 100. So when you calculate it, so here it will be like 203 times 30, that will be 6090 plus 205 times 70, that is 14350 divided by 100, and the answer would be like should be one decimal place. So here after calculation there will be 204.4. Okay, now the next question, question number 3. This question is about silver iodide. You can see here the silver iodide, that is the product. So here is the production. There is a double displacement reaction occur in between silver nitrate and sodium iodide, and the product will be silver iodide and sodium nitrate. Okay, now the question is, a student investigated the law of conservation of mass. So here is like the all the information is present. Okay, now the question is, explain how the result demonstrate the law of conservation of mass. You should use data from table 3 in your answer. As we know that because that question is 2 marks, so first identification you can write that the mass of the reactant according to law of conservation of mass, the mass of the reactant or the reactant mass is equal to product mass. Alright, so if you add up the reactant mass here like 78.26 and 78.50, then the answer will be 156.76 grams. Alright, and in case of like the mass after mixing in grams, so here like the product mass will be 108 plus 48. So you can see here 6 7 6 5 1. So you can see here but the both masses are equal to each other. Okay, now the next question, suggest how the student could separate the insoluble silver iodide. Because if you see in the reaction, so that is like the state that is given, that is solid. So it means silver iodide is solid state, is in solid state, or insoluble silver nitrate. So that is the common method for like the separation of insoluble compound, that is filtration. Alright, okay, next question. The student purified the separated silver iodide. This is the method used, like rinse the silver iodide with distilled water and warm the silver iodide. Suggest one impurity that was removed by the rinsing with water. As we know that like during the, like for example, in the double displacement reaction, when there will be two products that are produced in the reaction, and if the one product is our desired product, then the other product will be our waste, that is the waste product. So here actually the waste product is actually, you can say, that is the impurity that is present in the reaction, so you have to remove that. So if you see here, that is the another product, that is the silver nitrate. So that silver nitrate is in aqueous form, so it means that is easily dissolved in the water. So that's why here the one impurity that was removed by rinsing with water, that is sodium nitrate, silver iodide, that is already formed, and that is our desired product. Okay, suggest why the student warm the silver iodide solution. So why? Because for warming to, you can say the heating process is due to like evaporate or removal of the water, for the removal of water. Okay, now the next question. Again, calculate the percentage economy of the production of the silver iodide in the reaction. So I think we already did the same type of question in our previous video, but here you can also see that the equation of the reaction, like the silver nitrate and sodium iodide, that will form silver iodide and sodium nitrate. So relative formula masses are given, so you have to find the percentage economy of the silver iodide, that one. Okay, so here the reactants are silver nitrate and sodium iodide, so you have to add up their masses. So 170 plus 150, that equal to 320, while the silver iodide is 235. So here 235 divided by 320, and that is percentage, so times 100, so that will equal to, and you have to write the answer in three significant figure. So three significant figure will be 73.4%. Okay, the next one, give any like one reason why reactant with have high economy are used in the industry. So that is the 1 mark question. So you can write any one, like here I am going to show you like the reasons, like for example, for sustainable development, that is the first reason. Or you can say that for economic reason. How the economic reason, like the produce a higher percentage of the product, produce higher percentage of desired product. Alright. Okay, next question. Question number 4 is about the electrolysis. So here is the positive electrode and negative electrode, and that contain a green copper chromate solution. Okay, now here the blue colored is like due to copper ions, and yellow colored is due to chromate ions. Okay, now here the table is also given that changes at positive electrode, that is the solution turns yellow, bubbles form at the electrode, while changes at the negative electrode, that are the solutions turn below and solid form are on the electrode. Explain why the color, question is explain why the color change at the positive electrode. So if you see at the positive electrode here in the table, that is solution turn yellow, and we can see that here in the information the yellow colored is due to chromate ion. So actually there is the movement of chromate ion towards positive electrode. So you can write CrO4 negative 2, that like that ions or these ions are moved towards positive electrode. Okay, while and why the color change? Because you can see the positive electrode and here the ions are negative, so it means that there will be opposite charges attract. Opposite charges attract. Okay, now the gas produced at the positive electrode was oxygen. The oxygen was produced from the hydroxide ions. So as you know that the hydroxide ions are present in the solution that containing like the water. So name one substance in the solution that provide the hydroxide ion. So here I already wrote, that is water. Okay, now next, here is 3 marks question. Describe how the solid form at the negative electrode. So negative electrode, the metal move towards the negative electrode. So you can say that the copper ion Cu+2, that will move towards negative electrode, and at the negative electrode what will happen? Copper ion that will take the 2 electrons to form copper solid. So here you can say that the copper ions gain 2 electrons to form copper atom or copper solid. Okay, now the next question. The student repeated the investigation using potassium iodide solution instead of copper chromate. Name the product at each electrode when the potassium iodide solution is electrolyzed. At negative electrode, so there will be like the more reactive, that will be towards the positive, and the less, that will be like higher electronegative, that will be moved towards the negative electrode. So here the iodide is present, so it means that like which one, like here the positive electrode, there will be negative ions that will be moved. So here the iodine, positive electrode iodine, while the negative electrode from the solution, that will be hydrogen. Alright, okay, next question. This question is about the development of scientific theories. So in 1890s to 1900, there are the 2 discoveries, like the electron discovered and plum pudding model. And while 1900 to 1910, so there are the sequence, so we will see. Okay, now the question is, the plum pudding model did not have a nucleus. Describe 3 other differences: the nuclear model of the atoms and the plum pudding model. So if you see that the plum pudding model is just like, here I am going to show you, there will be no nucleus and all contain like positive, negative, positive, negative, positive, negative. Alright. Okay. So now we are going to write the 3-1. Like if you see the first one, that is mostly the plum pudding model, that mostly having the empty space. So you can write mostly empty space. Okay, now the next one, like if you see the positive charges are not enclosed in the nucleus, they are spread throughout the model or throughout the atom. So you can say that positive charge in all the nucleus. Positive charge in all direction. Okay, and the next one, as you know that in nuclear model there will be the electrons and the nucleus are separated from each other, while there is no separation in between positive and negative charges, are in between the, like you can say, positive charge and the electron. So in plum pudding model there will be no separation in negative and positive charges. Alright. Okay, next question. Niels Bohr adopted the nuclear model. Describe the change that Bohr made a nuclear model. So as you know that the nuclear model, that will be, there will be a defined nucleus, and now they have like according to Niels Bohr, they like define like a shell or orbits. Okay, so here the electrons are present in the orbits or revolve around the like electrons orbits the nucleus, while the electrons are at specific, and the second one identification, and the second one you can say modification, that the electrons are at specific distance from the nucleus. So these are the two, like you can say, the changes in the Bohr model. Okay, next one. The Mendeleev published his model in 1869. Mendeleev arranged the elements in order to atomic weight. Mendeleev then reversed the order of some pair of elements. A student suggests Mendeleev's reason for reversing the order was to arrange the elements in order of atomic number. Explain why the student's suggestion cannot be correct. So here you can see, on the basis of or in order of atomic number, and Mendeleev published his periodic table in 1869. So as you know that the atomic number is represented by Z, that is actually equal to number of protons that are present in the nucleus. While if you see in 1869, okay, up to 1869 is here, like before 1890s, and the proton discovered in 1890, like closer to 1890 1820, or you can say closer to 1920, or you can say that 1918. All right, but the Mendeleev periodic table, that is about 1869. So it means that here you can write that protons were not discovered until here, like protons, because the protons were not discovered until later. Okay, now the last question, because that is the half video, so we will continue the other half video in the next like the other half, like the question paper, in the next video. So that is our last question in this video, that give the correct reason why Mendeleev reversed the order of some pair of elements. So because Mendeleev classified, you can see here in the statement, the Mendeleev arranged the elements in order of their atomic weight. So because here their properties match the rest of the group, you can write here their properties matched the rest of the group. Okay, so that's why Mendeleev's reversed the order of some pair of elements. So thank you for watching. Please subscribe our channel. So in the next video we will continue this question, like this paper. Okay, so take care. Goodbye.